That's our Gigabay. So we're expanding integration to produce 1,000 starships per year. That is a truly enormous structure. That'll be one of the biggest structures, I think by some measures, the biggest structure in the world.
At first glance, it looked like typical construction. But the cranes began to reach farther. As the steel skeletons grew wider, awe spread throughout the Kennedy Space Center. It's more than just pushing the limits of what SpaceX is building in Florida. It's unthinkable. This is the Gigabay, a 380-foot-tall facility designed to build starships and Super Heavy rockets on a scale never seen by NASA. Every day, progress is visible here. Every week, a new layer of sheer size is introduced.
It's really designed for how to make the most reliable rocket ever made.
Right.
So that is the fundamental goal.
Right.
The engineers who oversaw the Apollo and Space Shuttle programs now watch with awe as SpaceX transforms the history they contributed to. How far this revolution will go is now the question, not whether they can complete it. And we are here to reveal that secret. The paradigm change is the one that rises deep within the Kennedy Space Center, beyond the historic launch pads and tourist buses. You must comprehend the two entirely distinct realms of space travel in order to comprehend why this is such a significant event. Rockets are made sequentially by traditional aerospace, one vehicle at a time, and each unit takes months or years to construct. They will be produced concurrently in parallel across 24 work cells at SpaceX's Florida plant. Then SpaceX emerged with Concept. You were the pilot of SpaceX's Crew Dragon on its inaugural flight. How do you feel about the speed at which they are currently traveling? Their speed can only be characterized as unrelenting. SpaceX hopes to complete the project in a few years when a conventional project may take 10. They break the old norms by building, testing, failing, fixing, and then taking off again. It's like witnessing a new industrial revolution in fast forward as SpaceX moves at this pace. This construction's size and speed signify a new industrial strategy for space travel. Making a single flawless spacecraft is not the goal here. The goal is to construct a factory capable of producing them. A whole infrastructure created to make launching a starship is as simple as launching a plane. This system is fully integrated. It extends from the factory floor, where the rockets are created, to the launch pad, which launches them into the sky, to the amazing catching arms that return them home to resume their flight. The objective is straightforward yet revolutionary: to make space travel commonplace and reasonably priced. What does this system look like then? Let's examine the 7 main components of SpaceX's overall strategy for Florida. The enormous Gigabay plant, the enormous crane that makes it all possible, the revitalized historic launch pad, the incredible chopsticks that grab rockets, the sea bridge that supplies the operation, the ambitious plan for a whole spaceport city, and, lastly, the very real obstacles that still exist. The Gigabay is ahead. A structure so enormous that it redefines the term factory is at the center of this change. To say that this Gigabay is huge would be an understatement. Imagine a space center with the biggest building you can think of. The fabled Kennedy Vehicle Assembly Plant, where the moon rockets that Saturn favored were manufactured. Imagine now that the building's most important active component is stacked vertically. The Gigabay is that. Most city buildings are dwarfed by its height of 380 feet. It has more than 46 million cubic feet of space inside. To put it into perspective, its walls could accommodate many football fields piled on top of one another. This is more than just a missile shelter. It's a cathedral devoted to their construction. However, the Gigabay's actual brilliance goes beyond its size. It's what takes place within. 24 distinct work cubicles are intended to be housed in this structure. A work cell may sound like a dull office term, but in this case, it holds the key to a revolution. The Gigabay has 24 work cells working at once, as opposed to producing one rocket at a time. A team can work on a single starship or its enormous super heavy booster at each station, which is a self-contained space. It resembles an assembly line in an automobile factory, except instead of tiny automobiles traveling along a belt. The biggest and most potent rockets ever created are being produced in parallel. Is that why SpaceX was founded? We have spent 17 years preparing for the introduction of Crew. One crew might be welding a booster piece in Cell 5. Another might be setting up engines on a spaceship in Cell 12. And a third would be managing electrical systems in Cell 20. The unthinkable pace of building is made possible by this parallelized process. It implies that SpaceX could potentially have 24 rockets in different states of completion under one enormous roof, as opposed to producing one rocket at a time. This design was not created at random. This is Starbase 2.0. In Boca Chica, every single lesson was discovered the hard way. The plans for Florida have been heavily influenced by Texas. SpaceX discovered how weather could cause work delays in Texas. Thus, the Florida Giga Bay is a weatherproof structure that is completely enclosed. They gained knowledge of workflow constraints and how individuals and components could occasionally obstruct one another. Therefore, the layout is more rational, the material flow is smooth, and the crane courses are more intelligent in Florida. They acquired more effective building techniques. And this new facility incorporates all of those efficiencies. It's not the first time. It is an improved and enhanced version of the original. All of this efficiency and size points to one astounding objective. Elon Musk has discussed constructing 1,000 starships, despite the fact that very few people really did it. The gigabyte is the instrument that makes that ambition mathematically feasible, even though it sounded like science fiction to many. Consider it. If each of the 24 work cells can only manufacture a few rocket sections annually, the numbers quickly mount up. This structure symbolizes the critical shift from the prototype to the mass manufacturing stage. The Starship is no longer regarded as a one-of-a-kind handmade device. Like automobiles or airplanes, it is becoming a commodity, a standardized vehicle that can be manufactured in large quantities. Everything is altered by this transition. It's the distinction between a steel mill making steel and a blacksmith meticulously crafting a single sword. Sufficient steel to construct a fleet. The gigabyte is the star's steel mill. SpaceX is not merely experimenting with space exploration, as evidenced by its very existence. For it, they are constructing an industrial base. And it all begins right here, inside the walls of this enormous new factory. The enormous apparatus. This is merely half the tail of a skyscraper, this massive. You need tools that are commensurate with the goal in order to fill it and construct the launch site. This brings us to the L-13-0 crane, a monstrous piece of equipment that will soon dominate the Florida skyline. This isn't your typical construction crane. This is the most strongest conventional crawler crane in the world. A legend in the heavy lifting industry. It is an event in and of itself when it arrives. It doesn't arrive undamaged. It comes in a sluggish, long procession of flatbed trucks, each of which is transporting an important part of the beast. It resembles a massive metal puzzle that comes to life. Its enormous structure is meticulously put together over the course of days, occasionally weeks. The counterweights alone are massive solid steel blocks that weigh hundreds of tons and require careful placement. Before it can even start doing its actual task, this machine needs its own intricate construction project. What is it then? Enormous task. Prior to launch, it must raise and position the orbital launch platform, the enormous base that will support the Starship and super heavy booster. This is more than just a concrete slab. It is a multi-level, intricate steel structure that weighs thousands of tons and is bristling with cryogenic fuel and water pipes. An incredible 3,000 tons can be lifted by the LR-1300. Imagine attempting to lift 40 fully loaded semi-trucks at once to get a sense of that figure. That is the unadulterated, astounding power needed to construct a launch pad for the most potent rocket ever made. This is when the story really picks up, as it demonstrates how SpaceX develops and learns. Take a look back at Texas Starbase. To perform the same task, SpaceX required two LR-11NOS-U units, which are extremely strong cranes, to operate in perfect harmony. It resembled a high-stakes slow-motion ballet starring two giants. Every step had to be precisely coordinated by the two crane operators. Their machines are working together. The entire operation might collapse catastrophically and costly with just one incorrect calculation and a small miscommunication. It was slow, extremely intricate, and nerve-wracking, but it worked. A more intelligent approach is being demonstrated in Florida. The powerful LR-1300 is the only crane they are employing. The combined power of those two Texas cranes is less than that of this one piece of equipment. The shift is a concrete illustration of optimization and learning. They eliminate a great deal of complexity and possible sites of failure by using one crane rather than two. They considerably lower the likelihood that something will go wrong. Because they only require one crew and one machine for setup, transportation, and operation, they save money. Most significantly, they significantly accelerate the entire procedure. It's a more straightforward, astute, and self-assured method of construction. Nevertheless, the LR-13000's gentle touch is its most significant attribute. Despite its raw power, without accuracy, power is worthless. It takes more than just dumping the launch mount into a large hole to place it. It needs to be precisely aligned at the millimeter level, which is finer than a pencil lead's width. Consider the physics at play. This platform will hold the entire rocket, which is almost 400 feet tall. The engines will push straight down as soon as they start. The rocket's stability during launch may be impacted by asymmetric loads if the mount is even slightly wrong. For the rocket to fly straight and true and provide a secure base for its orbit, the launch mount needs to be precisely level and positioned. We are about to make that happen on American rockets launched from American territory. Start Complex 39A. In the history of space travel, Launch Complex 39A is revered. The Apollo program's powerful Saturn V rockets set out from this exact location to transport people to the moon's surface. For more than 30 years, the space shuttle fleet roared to life out of this same concrete. Here, giants' ghosts roam. And now, in preparation for its next and possibly most dramatic act launching, Starship, this hallowed stage is being entirely rewritten. This complete change has a straightforward explanation. Starship is more than just a larger rocket. It is a natural force. There were 5 massive engines on the Saturn V. There were 3 on the Space Shuttle. Sitting atop its super heavy rocket, a Starship has 33 Raptor engines running at the same time. This historic sight has never experienced anything like the loudness, vibration, and sheer raw power. Despite its strength, the old infrastructure would be completely destroyed. Deep beneath the rocket's intended location, SpaceX is rebuilding it from the ground up, including all the lessons gained during its testing in Texas. The concept of the flame trench is being entirely rethought. During launch, this channel sends the amazing fire and energy away from the rocket. It's more than simply a trench for Starship. The new orbital launch mount is supported by this survivability mechanism. There are now 4 enormous legs. These pillars are not straightforward. These intricate constructions are packed with ducting and hydraulic systems designed to withstand stresses that would break traditional concrete. For the duration of the launch, they serve as the fundamental shock absorbers. The water deluge system is another. The first line of defense for Starship is this. Millions of gallons of water will be pushed through the system in a handful of seconds during launch. This isn't a light mist. It's a controlled, forceful flood. The water performs two vital functions. It reduces sound waves and immediately cools the steel structures from the intense heat of the engines. If allowed unchecked, the acoustic energy from 33 engines may produce vibrations intense enough to harm the rocket itself. This water shower shields the vehicle it is launching by acting as a massive sound absorber. To generate this deluge, the system needs massive water tanks and strong pumps, all of which are being incorporated into the new architecture of the pad. The Pad B principle, as it is commonly known, is advantageous to the entire new design. This is our Dragon spacecraft's engineering test article. The engine parts are located here. Pad A, the first launch pad, was constructed in Texas, under the actual strain of a launch. They discovered what worked and what failed in the prototype. The mature version, Pad B, is located at 39A in Florida. Every area of weakness found in Texas has been reinforced. From the beginning, every improvement has been incorporated. For example, the welding methods are probably more sophisticated. The steel is probably of a higher grade, and the pipe and cable layout is more sensible and secure. It's not a guess. Because of its thoughtful and elegant design, the Florida pad is more durable and dependable from the start. It is the distinction between the first model to come off a refined manufacturing line and a hand-built concept car. The tank farm is a new landscape that is emerging around the pad. This assortment of enormous silvery cylinders and spheres resembles an industrial church. Every tank has an essential goal. The biggest ones hold liquid oxygen, which is the oxidizer needed for rocket fuel to burn in space's vacuum. The clean-burning fuel for the Raptor engines, liquid methane, is stored in additional tanks. Since methane is a fuel that might be produced on Mars, it is crucial. Additionally, nitrogen, an inert gas needed to pressurize systems and clear lines of hazardous gases, is contained in the characteristic spherical tanks. When combined, they create a sophisticated gas station that is intended to power a journey to a different planet. These supercooled liquids will be transported by the intricate network of insulated pipes that joins them at the exact moment they are required for launch. The most astounding aspect of the endeavor as a whole is probably that all this groundbreaking work is taking place while the pad's original function remains unaltered. Falcon 9 and Falcon Heavy rockets continue to launch on their regular timetables, transporting satellites and astronauts into orbit just as stones are thrown away from the Starship building zone. This demonstrates a remarkable degree of operational dexterity. It would be comparable to upgrading a passenger bus's engine and base entirely while it is still traveling down the highway. Construction, heavy transportation, and live launch activities must all be carefully managed concurrently by the team. A never-before-seen ballet of time and logistics. They must make sure that a Falcon rocket won't be hampered by building dust, that the entire area stays safe for each mission, and that work schedules don't interfere with launch countdowns. Today, Launch Complex 39A is defined by this potent reality. It is a place that persistently pushes into the future while paying tribute to its past. It is a location where the thunder of a new machine being constructed to advance humanity meets the echoes of Apollo missions. There is more to the change than just an improvement. In order to make sure that this fabled portion of Earth serves as the main stepping stone for humanity's trip to the Moon, Mars, and beyond, it is a passing of the torch. This work links the most lofty aspirations of the future with the noblest accomplishments of the past. The chopsticks. The chopsticks are the most astounding aspect of the whole process. Although the moniker may appear lighthearted, their goal is really serious. It's not a gimmick. It is essential to Starship's quick reusability. What transforms a revolutionary rocket into a true spaceship is the capacity to catch the enormous Super Heavy booster as it descends from the sky and then gently set it back on the launch mount. One that, rather than taking months, can fly once more in a matter of hours. How do you catch a building then? The system as a whole is a mechanical engineering marvel. Imagine the launch tower. The carriage is a huge platform that runs up and down its side. NASA's 7th cargo resupply mission to the International Space Station was launched by SpaceX. The chopstick arms are fastened to this carriage. It's not just hanging there. A set of grippers, sometimes referred to as skates, clamp onto rails on the tower's legs to secure it to the tower. This enables the complete multi-tone assembly to move up and down with the accuracy and steadiness of a high-speed elevator. The two enormous chopstick arms themselves are now fastened to this chariot. They might close in to grasp the booster after opening wide to receive it. However, they don't simply pick up the rocket anyplace. Special strengthened pegs protrude from the side of the booster. These pins are intended to be closed by the chopsticks, resulting in a strong and safe connection. It's an advanced pin-and-hole system on a skyscraper-sized scale. But the catch is where the true magic lies. It's not exactly gentle when the 230-foot-tall booster lands. There is a lot of kinetic energy in this controlled fall. The impact would break both the arms and the rocket if the chopsticks were totally inflexible. They are therefore made to be intelligent. The extensible catch rails on the arms serve as a kind of shock absorber. Imagine a baseball catcher who, in addition to keeping their mitt rigid, pulls their arm back to lessen the force of the catch. Similar to this, chopsticks move backward just enough to absorb the massive forces and bring the booster to a safe, smooth halt. The device can then lower the entire rocket to the Earth following the catch. This amazing achievement has evolved from a fantastical concept to a proven reality. At their Texas Starbase facility, SpaceX has successfully captured boosters. Every capture has yielded invaluable data and been a learning experience. The precise speeds, approach angles, and the way the rocket sways in the few seconds before landing have all been revealed to the engineers. Every minute, motion has been examined. The Florida systems are now directly hard-coding these lessons. The hardware is better, the software is more intelligent, and the processes are more polished. What used to be an amazing test is about to become a common practice. However, the idea for Pad 39A goes beyond a single pair of chopsticks. The goal is far higher. SpaceX is already constructing another set of these enormous catching arms at the Roberts Road site, which is located beneath another enormous tent. These are not compatible with the existing pad. They are intended for launch locations in the future, such as Space Launch Complex 37. The broader strategy is revealed by this crucial detail. Infrastructure for a single launch site is not being built by SpaceX. A production line is being built in preparation for launch, as well as recovery towers. Because they intend to have a whole fleet of starships, they are constructing an entire fleet of these systems. The chopsticks are more than simply a useful tool. They are the key that opens the door to regular and reasonably priced space travel in the future. SpaceX is guaranteeing that its massive rockets become reusable assets rather than two. Ruby Kiss, Ruby Kiss. Only Ruby Kiss. Only Ruby Kiss has the luxurious texture that slide sees. Not CPS.CES, it's Siplist.CE. Long-lasting color, Maya Simmery. It's Siplisecti, CS, it's a cup to loss. No wall last, CS, we see Maya, we are CS. We see my Wally with CF, PA, my CS, I wit, Gilias, Kit said, we so I sigh kid. They sigh, psaka, say we say I so we did it I seek a kit to beat till it sit to succeed to set to deter pews at the blood and sits it Throw away fireworks by perfecting quick booster recovery. This completely upends the economics of space travel and makes it possible for ships to, in the end. This isn't just SpaceX building rockets, it's humanity building its next era. Inside these towers, cranes, and steel giants, a new form of space travel is taking shape. Faster, cheaper, reusable, relentless. What began as experiments in Texas is becoming a full-scale industrial revolution in Florida. And when the first Starship lifts from this new factory of the future, we won't just be watching a launch, we'll be watching the moment. Earth truly becomes a spacefaring world. Journey continuously to orbit, the Moon, and ultimately Mars.